Good morning, students. Today let us study the conformational isomers of 1,2-dichloroethane. Okay. Now what is the formula of 1,2-dichloroethane? Ethane molecule is C2H6 or CH3CH3, correct? So one hydrogen atom of one carbon atom replaced by chlorine atom, and the other hydrogen atom of another carbon atom replaced by chlorine atom. Okay. So that's how we get 1,2-dichloroethane, and ethane molecule, you know, there are two carbon atoms. Okay. So both these carbon atoms, one hydrogen atom replaced by chlorine atom. Okay. That's how you get 1,2-dichloroethane. Alright. Now these are the various conformational isomers of 1,2-dichloroethane. Okay. You can see here front carbon atom is here. Okay. Back carbon atom is represented by a circle. Okay. And CH2 of one carbon atom, first carbon atom or front carbon atom. Okay, this is the CH2 group of front carbon atom. Rear carbon atom is this. Okay, rear carbon atom is this. Now this chlorine atoms together, if they are existing together, or hydrogen atom and chlorine atom existing together. Okay, this conformations are called eclipsed conformation. Okay. So two hydrogen atoms or two chlorine atoms, okay, together or very close neighborhood, if they are present, that is called eclipse conformation. Okay. So number 1, okay, and then 3, third conformation, and then fifth conformation. Okay, fifth conformation are eclipsed conformations. Okay, and first one is similar to sixth one. Okay, the sixth structure, this is the first structure. After 6 you have first structure. Okay, so this structure and this first structure same. So altogether there are 6 conformations. So 1, okay, 1, 2, 3, 4, 5, 6. Okay, total 5. This is similar to first structure. Okay, so the eclipsed conformations are first one, okay, third one, and then fifth one. Okay. Now what about staggered conformation? What do you mean by staggered conformation? If chlorine atoms and hydrogen atoms are in between, that means staggered. Okay, far away, like this, second conformation. Okay, and then here fourth conformation. Okay, fourth conformation, and then what? Sixth conformation. So these are called staggered conformation. Okay, next slide. Now two distinct eclipsed conformations are possible. One in which chloro group is eclipsed by a chloro group, as in one you have seen in the structure 1, 2 chlorine groups are together present, 2 hydrogen atoms are together present. Okay, so that is one type of eclipsed conformation. Okay, and the other in which the chloro groups are eclipsed by hydrogen. Okay, third and fifth, this also you have seen. In third and fifth structure, chlorine and hydrogen atoms are in the very close neighborhood. Okay, so this is also another type of eclipsed conformation. Eclipsed means together. Okay, in the close neighborhood. Okay, of the two eclipsed conformations, 1 and 3 or 5 conformation, fifth conformation. Okay, one experiences more repulsive forces than 3 and 5. Okay. The conformation 1 experiences more repulsive force, okay, than third and fifth. Okay, where chloro groups are phased with hydrogen atoms. Okay, thus conformation 3 or 5 is more favored. Here first conformation, okay, 2 hydrogen atoms are in the close neighborhood and 2 chlorine atoms are in the close neighborhood. That means like atoms are together exist. Okay. So here there is more repulsive force. Okay, this is more repulsive force. Okay, whereas third and fifth one, hydrogen and chlorine atoms are together. Okay, so here repulsive force is less. Okay, therefore this conformation is more favored. Okay, 3 and 5 is more favored. Why it is more favored? The two atoms present in the close neighborhood are unlike atom. That means hydrogen and chlorine. Okay. Therefore, it is more favored. That means repulsive force is less. What about first conformation? 2 hydrogen atoms together exist, 2 chlorine atom together exist. Therefore, like atom, therefore more repulsive force. Therefore, it is not favored. Okay, not favored. Next point, Similarly, 1,2-dichloroethane has two different staggered conformations. Okay, staggered means far away. Okay, so there are two different staggered conformations. Okay, 2 and 4 or 6. Okay, 2 and 4 or 6. All right. Next slide. Number 2, that means second conformation or sixth conformation. Chloro groups are at an angle of 60 degree. Okay, it is not 600, 60 degree to each other. So this also you have seen. This is called gauge conformation. Okay, what is gauge conformation? In this case, two chlorine groups. Okay, that means chlorine atoms are at an angle of 60 degree. So that is called by a special name. Okay, that is called gauge conformation. Then what about fourth one? In fourth, the chlorine groups or chlorine atoms are okay at an angle of 180 degree. Okay, it is 180 degree, angle of 180 degree to each other. This is called anti or trans conformation. Okay, so in fourth conformation, the two chlorine atoms are at an angle of 180 degrees. So that type of conformation is called anti or trans conformation. Okay, so there are two types of this staggered conformation, gauge conformation and trans conformation. What is gauge conformation? Two chlorine groups are at an angle of 60 degree. What about anti or trans conformation? Two chloro groups are at an angle of 180 degree. Okay, 180 degree. Next point, the repulsive forces will be greatest in 1 due to the proximity of chloro groups than in 3 or 5. This you have noticed, okay, in the previous structure, okay, previous slide. So repulsive forces will be great in 1 because two like groups are adjacent to each other than in 3 or 5 conformation. Okay, the gauge conformation, okay, 2 and 6 have slightly higher energy than trans conformation. Okay, which is associated with least energy. So trans conformation is having least energy, whereas 2 and 6 having higher energy. Okay, slightly higher energy. And maximum stability. So least energy means that conformation will be having maximum stability. Okay, maximum stability due to least steric strain. So steric strain will be less in that. So they are more stable or maximum stability. Okay, next slide. Now here there is a graph showing potential energy along the y-axis, degrees of rotation along the x-axis. Okay, so degrees of rotation starting from 0, okay, 0 degree, 60, 120, 180, 240, 300 and 360. Okay, now what about the potential energy? Potential energy for the eclipsed form, that is first conformation. Okay, that is what? Highest potential energy. Okay, then staggered form, second one conformation is staggered form, less potential energy. Okay, you can see here less potential energy means it is more stable, high potential energy means less stable. Okay, now eclipsed form 3, third conformation having higher potential energy but less than first one. Okay, then fourth one less potential energy, that is lesser than staggered second conformation. Okay, so this is the most stable one, you can see. Okay, in the graph, staggered fourth conformation is the least potential energy, therefore it is more stable. Okay, more stable. Then eclipsed one, fifth one is eclipsed, once again higher potential energy. Next, the sixth conformation, again less potential energy, therefore it is stable. Okay, so this is the graph showing potential energy versus degrees of rotation. Okay, next slide. Now, what are the conformation isomers of cyclohexane? Okay, now for this you must know what is the formula of cyclohexane. What is cyclohexane? It is nothing but hexagon, represented by hexagon. Okay, without the alternate double and single bonds. If you put alternate double and single bond, it becomes what? Benzene, correct? So without alternate double and single bond, just if you draw the hexagon, that means it is what? Cyclohexane. That means each corner contain carbon atom, 6 corners contain carbon atom and 2 hydrogen atom, correct? So CH2, 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 like that 6 corners present. Okay, so that is cyclohexane. Now a single cyclohexane molecule is in a continuous state of flexing or flipping into different shapes or conformations. Okay, you can see here. Okay, you can see here different conformations. Okay, different conformations. Which are the different conformations? Chair form, and then what? Here chair form. Okay, chair form, half chair, and then a twist boat, and then boat form. Okay, boat form. So chair form is this. Okay, looks like chair. Then this is half chair, okay, looks like broken chair. This is a twisted board, twisted like, okay, this is somewhat like boat. So these are the different conformation isomers of one cyclohexane, okay. So this chair form can gets converted into boat form, okay, or half chair form or twist boat, okay. It will be continuous changing, okay. Next slide. Now these conformations arises due to the rotation. Now how these conformations arise? That arises due to the rotation of around what? Carbon-carbon single bonds. You know that cyclohexane contains carbon-carbon single bond, correct? CH2 single bond, CH2 single bond, like that 6 corners, correct? So it is due to rotation across what? This carbon-carbon single bonds. The chair form and the boat form are the two extreme cases. You can see here chair form, boat form are two extreme cases. Potential energy, if you draw the graph along the y axis, this is the chair form, okay, lowest potential energy, that means what? More stable it is, okay. So chair forms are more stable, low potential energy. What about half chair? High potential energy, that means less stable, correct. Then boat form, little less potential energy is lesser than half chair, so it is a little bit more stable than what? Half chair, okay. So twist boat, okay, boat, this is boat form, okay, half chair, okay, half chair, this is chair form, okay, chair form. And energy from chair form to half chair is, okay, potential energy 11 kilocalorie per mole, okay. Then boat form 7.1 kilocalorie. What about twist boat? This is twist boat, okay, this and this. So 5.5 kilocalorie per mole, okay. Next slide. The chair form has least energy. So you know that from the graph chair form has the least energy, correct. So while the half chair has the highest energy. So half chair has got highest energy, highest peak means highest energy, okay. So it is less stable, least energy means it is more stable. So at any given time, almost all the cyclohexane molecules, okay, that means 99.9% are in chair form, okay. Since cyclohexane in the chair form has got least potential energy, most of the molecules of cyclohexane, that means 99.9% exists in which form? Chair form, okay. Now in cyclohexane, okay, you know that each carbon atom contains 2 hydrogen atoms, correct, CH2 CH2 like that. So out of these 2 hydrogen atoms, okay, one is called equatorial hydrogen and the other one is called axial hydrogen atoms, okay. Both are not same, one is called equatorial represented by He and other one is called axial represented by Ha, okay. Examinations of the chair form of cyclohexane reveals that the hydrogen atoms can be divided into 2 categories, okay, 2 categories, which are those? Equatorial and axial hydrogens, alright. 6 of the bonds to hydrogen atoms point He, okay, straight up or down. What is He? That means equatorial hydrogen, they straight either up or down, okay, almost perpendicular to the plane of the molecules. So perpendicular to the plane of the molecules. So they straight point upwards or downwards, okay, perpendicular plane of the molecules. These are called axial hydrogens, okay. They are called by a special name, they are axial hydrogens, okay. So axial hydrogens pointing straight up or down, okay, straight up or down, okay, they are called axial, okay. Then equatorial means they are slightly above or slightly below the plane, okay. The 6 hydrogen atoms slightly above or slightly below the plane of cyclohexane rings, they are called what? Equatorial hydrogens, okay. Next slide. Now what are the differences between conformation and configuration, okay. Conformation is the spatial arrangement of atoms in a molecule that results through free rotation of atoms about a single chemical bond, okay. Conformation is nothing but spatial arrangement, okay, and you will have different way of arrangement, spatial arrangement. How it takes place? It takes place through free rotation across one single chemical bond, okay. So about a single chemical bond there exists free rotation. Where free rotation takes place? Spatial arrangement, okay. So that is called what? Conformation. It can be changed without breaking bonds and can be interconvert rapidly at room temperature, okay. So you can change from one conformation to another conformation without breaking bonds. You can freely rotate, okay, the atoms without breaking bonds at a room temperature, okay. For example, eclipsed, skew and staggered conformations of ethane, okay. So you know that in ethane you have eclipse structure, skew structure and staggered conformation. So you can rotate freely, okay, without breaking bonds. Because they interconvert rapidly, conformation isomers or conformers cannot be isolated. Since they interconvert from one form to another form, they cannot be isolated. Okay, rapid conversion will be possible, therefore they cannot be isolated. So you cannot separate them. Okay, so conformations cannot be isolated. Okay, next slide. Now what is configuration? Configuration is the permanent geometry of a molecule. Okay, configuration is nothing but permanent geometry of a molecule. Okay, it refers to spatial arrangement of atoms that can be changed only by breaking bonds. So configuration is also spatial arrangement, but what? By breaking the bond. Whereas conformation without breaking the bonds, whereas configuration by breaking bonds. Okay, example R and S configuration. This also you have learnt in the previous slides. Okay. So R and S configuration. Since configuration does not change or interconvert under ordinary conditions, compounds with a specific configuration can be isolated. So this can be isolated. Okay. So here breaking of bonds takes place when you change from one form to other. Okay. So you can isolate them. Okay. So configuration can be isolated, whereas conformation cannot be isolated. Okay. So with this chapter is over. Okay. Please go through all these slides. Okay, any difficulty please contact me. All right, thank you.